Hello, my name is Seven Data Student with the matrix number BB221109121. I'm going to present part 1 and part 2. So for part 1, construct appropriate graphs or charts to compare the relative frequency and cumulative relative frequency between the two metrics. So the two metrics are number of visits in million and number of purchase order in million. So according to the data, it was mass, so it's hard to find the frequency. We need to change it into ascending order from small to big so that we can make the range easily and find the frequency. So for the visits, the range will be 21 until 30. The second range will be 31 until 40. The third range will be 41 until 50. And the last range will be 51 until 60. Just refer to the data given. So for the first range frequency is 4. Second range frequency is 14. Third range frequency is 10. And the last range frequency is 2. Next, to find the relative frequency, we must divide the frequency with the summation of frequency. So the summation of frequency is 30. So frequency divided by total summation. First range, it will become 0.13. The second range will become 0.47. The third range will become 0.33, and the last range will become 0.07. And last, we're going to find the cumulative frequency. The cumulative frequency formula is by adding the relative frequency. So the first range will still stay at 0.13. The second range, when you add the first and second range, it will become 0.60. The third, when you add the range 1, range 2 and range 3, it will become 0.93, and the last range, when you add it all, it will become 1. So the final answer is 1. Next, we're going to find the frequency for purchase. The first range frequency is 111 and 100 to 140. Second range 141 to 170. Third range 171 to 210, and the last range is 211 and to 240. First range frequency is 7. The second range frequency is 11. The third range frequency is 9, and the last range frequency is 3. So next, we're going to find the relative frequency. The formula is still the same. When you add the frequency for purchase, it's still 30. So the first range will become 0.23. The second range will become 0.37. The third range will become 0.30. And the last range will become 0.10. So the cumulative frequency is still the same formula from the visits. So the first range will still stay the same, 0.23. The second range, when you add the first and second, it will become 0.60. And the third range, after you add the 3 range, it will become 0.90, and the last range, which is the fourth range, it will become 1. So the final answer is also 1. So these are the graph of comparison for relative frequency and cumulative relative frequency between the two metrics. So for the relative frequency, I'm using the line graph. The blue line is for visits and the orange line is for purchase. For cumulative relative frequency, I'm using the graph bar. So the blue is also visits, and the orange is purchase. As you can see, there are difference between the visits and purchase for relative frequency and cumulative relative frequency. Part 2. Calculate and compare measures of central location between the two metrics. So there are three measures of central location, which is mean, median, and mode. So to find the mean, the formula is all summation of values divided by total numbers of values. So for visits, when you use the formula, it will become 37.71, and the purchases, it will become 166 and 82. To find the median, the formula is we need to find the middle number from the total number of values. So first we change the data into ascending orders from smallest to largest, and then find the mid number. Since the total values of numbers is even, so we add the two total numbers in the mean and divided it by 2. So the answer for visits will become 34.5, while the purchases will become 163.9. And the last one, for the mode, we need to find the number that appears the most. So for visits, it will become 34.1, while the purchases, there's no numbers that appears the most, so there are no answer.
For part 3, the question is calculate percentile and box plot for each matrix. Construct box plot for each matrix. The box plot is constructed from 5 values: the minimum value, the first quartile, the median, the third quartile, and the maximum value. So the minimum value for visit is 23. The maximum value is 54.2. The 25 percentile is 31.95. The 50 percentile is 34.5. The 75 percentile is 45.43. As the result, the box plot for visit is positive skew. While for the purchase, the minimum value is 116.5, the maximum value is 231.9, the 25 percentile is 140, the 50 percentile is 163.9, the 75 percentile is 197.55. As the result, for purchase, the box plot is also positive skew. First step is to find the range, the maximum value minus the minimum value. So as the result for visit, the range is 31.2. For the purchase order, the range is 114.7. The number of purchase order has the greater range compared to the number of visits. From this, we can see that the number of purchase order shows more variability or a wider distributions of values. Step 2 is to find the MAD, mean absolute deviation. To find the MAD, we need to find the sum of the matrix first. The sum of the matrix represents the total value of the matrix across all data points. The sum of number of visits is 1131.4, while the sum of number of purchase orders is 3505.2. This indicates that the total number of purchase orders is higher than the total number of visits. After that, we need to find the mean. The mean represents the average value of the metric. The mean of number of visits is 37.71, while the mean of number of purchase orders is 166.82. This suggests that, on average, there are more purchase orders compared to the number of visits. MAD, the mean absolute deviation, measures the average absolute difference between each data point and the mean of the metric. The MAD of number of visits is 36.46, while the MAD of number of purchase orders is 112.95. A higher MAD indicates a greater dispersion or variability in the data. In this case, the MAD of the purchase order is larger, suggesting that the data of the purchase order is more variability than compared to the number of visits. By comparing the two metrics, we can see that the number of purchase orders has a higher sum, mean, and MAD compared to the number of visits. This indicates that the number of purchase data has a higher total, higher average, and a higher variability compared to the visit data. Third step is to find the variance in standard deviation. The variance measures the average squared deviation of each data point from the mean. A higher variance indicates a greater dispersion or spread of values. In this case, the variance of number of purchase order is larger. This suggests that the number of purchase order data has more variability compared to the number of visit data. The standard deviation is the square root of the variance. It represents the average amount by which data points deviate from the mean. A higher standard deviation indicates a great dispersion or spread of values. As we can see, the standard deviation of the number of purchase orders has a higher values compared to the number of visits. This suggesting that the data of the purchase order has more variability compared to the number of visits data. Last step, we need to find the CV, coefficient of variation. As we can see, the CV of the number of visits is slightly higher than the CV of number of purchase orders. This suggests that the number of visits has a slightly higher relative variability compared to the number of purchase orders. However, the difference in the CV coefficient of variation between the two metrics is relatively small, indicating that both metrics have a similar level of dispersion relative to their respective means.
Okay, as you can see here, for covariance is the mean for number of visits is 37.71, and the mean for number of purchases orders is 166.82. And for the formula is stated here. So for example, Lazada e-commerce 53.8 minus 37.71 multiply with 199.4 minus with 166.82, and we got the answer for 1073.169. Next, for the simple covariance is SXY same as 6558.2839 divided with 30 minus 1, and we got the answer for 226. Next is population covariance. As the formula stated here on the white paper, so we put 6558.2839, we divided with 30, and we got the answer for 219. So next, for the correlation, as you can see here, the formula is RXY same as SXY divided with SXSY. So we put 226 divided with negative 53.35 multiplied with 9.8, and we got the answer of 0.43. So the last one is population correlation, RXY. We put 218 divided with negative 53.35 multiplied with 9.8, and we got the answer for 0.42.